All right, so I'm going to skip the first few of these. For 33, a scatter plot, they're telling you that when x is 2000, your x value is 0, so 0, 1, 2, 3, so on. And all you're doing when you're drawing a scatter plot is you're just plotting the points. So you have 0 and 514, 1 and 514, etc. And then from here, you're writing, so that means you're using the points from 2001 and 2006 to then come up with a linear equation. So I just went over at the end of the last video how you can find the linear equation when given 2 points. And then it's going to say for the next one, estimate the score in 2007. Well, that means your x will be equal to 7. So you just substitute that into the equation you got to be, and then you're going to compare it to what you had. And then when you're predicting the score for 2010, x is then equal to 10. 34, I already did one like that in the last video where I did the perpendicular line. Remember, when it's parallel, you're just going to use the same slope. 35, 36, you just need to just find the slope of the line by picking 2 points. But just remember, here it tells us it's negative 10 by negative 10, so that means all of these are changing by 1. And this one, it tells us our y is negative 25 to positive 25. So that means all these are changing by 5s. So this would be 5, 10, 15, 20. So just make sure you're aware of that when you're picking your points. Same thing here. You can find your slopes and then just determine if you need help with any of these, 33, 34, 35, 36, just let me know. And I'll make sure I make a video specifically for that. But since we kind of already went over this, I'm going to skip that a little bit. All right, I'm going to go through some of these. I'm going to skip 37 because this one hopefully you're able to do. For number 38, all right, I'm going to do 38. So for 38, you have x minus 2 over top of 3 plus x plus 5 over top of 2 is equal to 1/3. So we have fractions. Usually no one likes to deal with fractions. So what we want to do is we want to multiply by the least common multiple, or if we were to go ahead and try and add all these together, our least common denominator, we'll multiply everything by that. So if we write our multiples out, we have 3, 6, 9, 12. For 2, we have 2, 4, 6, 8, 10, and 12. So although they both had 12, 6 is our least common multiple. So that means I'm going to multiply every single term by 6, right? Since I'm multiplying everything by the same number, I'm not changing any of its values, but what we're doing, 3 goes into 6 twice, so now I'm left with 2 times x minus 2, which will then give me 2x minus 4. 2 goes into 6 3 times, and now I'm left with 3 times x plus 5, so this would then be plus 3x plus 15. And 3 goes into 6 twice, so I'm just left with is equal to 2. So by doing my least common multiple, I get rid of all my fractions, and now this is just a linear equation that's easy to solve. 2x plus 3x is 5x. Negative 4 plus 15 is plus 11 is equal to 2. Subtract over the 11. 5x is equal to negative 9. X is then equal to negative 9 over 5. All right? So when you have fractions like this, especially when there's no variable in your denominator, you can just multiply by your least common multiple, and then that way you can clear everything out. If there is a variable in your denominator, it just becomes a little bit more that you have to do. All right, and then the other thing you need to be aware of is if this was a minus sign, then you will need to go ahead and distribute this minus sign in either after you multiply by the 3, or when you distribute the 3, you would distribute a negative 3 in to make this negative 3x minus 15. All right, so I went through and highlighted all the ones I'm going to go through with you in this video. I may break this video up into multiple videos. It just kind of depends on how long this one's taking. All right, but I'm going to skip some of these other ones because either they're duplicates or not duplicates, but similar to the ones I'm going through, or I think that you would know how to do this. So if you're not sure, just remember all you have to do is just reach out. All right, so for number 40, sometimes you do have to multiply and as we need to for another problem, and sometimes like multiply or distribute, or in this case FOIL, but sometimes you don't have to. When you don't have any other x terms besides just with this square, so you see here the only x that we have is associated with the square, that means we can get the square we can isolate the square first. So we don't have to FOIL this and then multiply by 3 and then set it equal to 0. You can if you want, but you're making yourself do a lot more work, and you're going to have to end up factoring it out or using quadratic formula. Since it's already already set up for us that x is being squared, and there's no other x part of our problem, we can then go ahead and divide by this 3, and we can then isolate our squares. So 3x minus 1 squared is equal to 7. And then we can go ahead and take the square root of this because there's no other x as part of our problem. So like for this one, we have 2x squared plus 8x. We can't just isolate the x and take the square root because there's another x that we have. But this one, the only x that we have is part of the square. So we can go ahead and quickly and easily solve for this. And remember, when something is being squared, it's a positive and a minus, because 5 squared is 25 and negative 5 squared is 25. So if I said x squared is equal to 25, when we're saying what squared is equal to this number, it generates both a positive and a negative answer. So then from here, we can go ahead and solve. We have 3x minus 1 is equal to a positive 7, or 3x minus 1 is equal to a negative 7. So we have 3x is equal to 8, or x is equal to 8/3, or 3x is equal to negative 6, or x is equal to negative 2. So in this case, we have two different answers, and when it's a plus or minus, you can't just say, okay, 3x is equal to plus or minus 7 plus 1. You have to actually go ahead and add anything that you can. All right, the next one I'm going to go over is number 42. So we have 16x squared minus 24x plus 7 is equal to 0. There are multiple ways that you can solve for this. There are mainly 3 methods that we use. The first one is by factoring. That's usually the one that we check first. The second one is completing the square. And the third one is quadratic formula. All right, now, quadratic formula will always work. Right? It always works. The problem is when you're doing quadratic formulas, sometimes you'll have these very large numbers. Sometimes it's a little bit more difficult for you to do, especially if you're not allowed to use a calculator. So a lot of people sometimes will go to this because it's always going to work, but some people don't like to use it because it could be a little bit more challenging. Completing the square only works when this number is even. Not only. You can use completing the square for almost all the times, but it's easiest when its number is even. And if you can factor a common factor out between these two, so you have just an x squared, or if you can take the square root of this number. So if you can do any of those things, then you can use completing the square. If you can't, it's either you can't use it or it's going to be pretty difficult using it. And factoring can work sometimes, not all the times. All right, so the first way, though, I always do it is I always look to see if it factors first, personally. It doesn't really matter which method you use. They're all going to get you the same answer as long as if they can be done. So for this one, I taught you guys the X method. If I'll go through 2 different ways that you can factor that I think work for this. Some people do guess and check. I personally don't think that is that great of a method. But when I do the X method, I draw an X. I put a multiplication sign here and an addition sign here to remind me. So then I multiply my A and my C, so my first and my third. And that will give me 112. And then this middle number just drops, whatever it is. All right, then I say what numbers multiply to 112 and they add to a negative number. So since they're multiplying to be positive and they're adding to be negative, that means that they both have to be negative, because the only way that 2 numbers can add to negative and multiply to positive is if they're both negative. All right, so that means I'm looking for numbers that multiply to 112 and add to 24. All right, so this actually can't be factored because there's nothing that multiplies to 112 that actually adds to 24. So this is actually a good example because if we can't factor, that means we have to use one of the other methods. Now, I'm going to go to completing the square, and I'll tell you why I'm going to go to completing the square. Because I can take the square root, or I guess I'm going to jump to, Yeah, all right. So I'm going to do completing the square, and I'll explain why. So when I'm using completing the square, I'm looking to see if this has a number other than 1 in front of it, can I factor it out of these two numbers? So I can factor out a 4 between 16 and 24. And when I factor out the 4, I'm left with, or let me just show you quadratic formula. It'll just be easier. So our quadratic formula, so that means I'm not going to do this one because I'm doing it now. It is negative b, so x is equal to negative b plus or minus the square root of b squared minus 4ac all over top of 2a. All right, so then I'm going to go ahead. My a is a number in front of my x squared. My b is a number in front of the x. My c is my constant. So then x is equal to negative of negative 24 plus or minus the square root of negative 24 squared minus 4 times 16 times 7 times 7 all over top of 2 times my a, which is 2 times 16. All right, so then our x is equal to 24 plus or minus square root of 576 minus 448 all over top of 32. So then we have x is equal to 24 plus or minus the square root of 128 divided by 32. Right now we need to go ahead and simplify this if we can. So we're looking to simplify the square root of 128. I'm going to do this here. So we look and see what can divide evenly. Can a perfect square divide evenly into this? Well, 4 is a perfect square. 4 goes into 128 32 times. So can we break down 32 at all? Yes. 32 is 4 times 8, and 8 is 4 times 2. So now we look and we say, okay, I can take the square root of 4, so I can take out a 2. I can take the square root of 4, so that's another 2. I can take the square root of 4, that's another 2. The square root of 2, I can't take the square root of it, so it must remain. So it's going to be times the square root of 2. 2 times 2 times 2 is 8 times the square root of 2. So this will then reduce to x is equal to 24 plus or minus 8 times the square root of 2 over 32. So now we look and see, are there any common denominator or common multiples that we can divide out of these three numbers? And yes, 8 goes into all of them. So I can divide all of these by 8. So our final answer is x is equal to 3 plus or minus the square root of 2 over top of 4. All right, so I know I start to do this when factoring first, and I hope that didn't confuse you, but it's a good example because sometimes you can't factor. So you may want to try and go factoring first, and if you can't, then you can go to another one. Now, because there's numbers in front of this as 16 and 24, I was going to try and show you completing the square, but I figured rather than doing one that's this hard first, at least this one it's a little bit easier. I'll just jump to quadratic formula to make it a little bit better for you. All right, so let's move on to the next problem. All right, so for 45, we have x times 2x plus 5 is equal to 4 times x plus 7. All right, so unlike the other one where it was set up for us that we could just divide and then take the square root, if we try to divide by x here, we can't get rid of anything. So for this one, we actually need to multiply this x and this 4 in order for us to try and solve this one. So this is 2x squared plus 5x is equal to 4x plus 28. All right, then after we do this, since we have x's and x squareds, we need to set it equal to 0. So I'm going to subtract over the 4x and the 28. So then we get 2x squared plus x minus 28 is equal to 0. Once again, we now have the three different methods that we can try and use to solve for this. And I'm going to go for factoring first. Let's see if factoring works this time. So we use the x method. We multiply here, we add here. So we do 2 times negative 28. So that will then give me negative 56. Whatever number is in front of our b, this drops, our 1. And now we're looking for numbers that multiply to 56 and have a difference of 1. Well, 56, 8 times 7. And the reason why I know that's a difference is because since this is minus, if they're multiplied to be to a negative number, that means one has to be positive, one has to be negative. 8 times 7 has a difference of 1 and multiplies to 56. Since this is positive, our 8 needs to be positive. All right, now, this is the spot that everyone always forgets. You divide, because we multiplied this 28 to get to this 56 by this 2. So we generated this number. So we need to undo the multiplication that we did. So we need to divide by our a. And then we reduce our fractions if we can. So 8 over 2 reduces to 4 over 1. And then we use the Drake song. Started from the bottom, now we're here. So this is the number that gets multiplied. So it would be 1x, started from the bottom, now we're here, plus 4, times, started from the bottom, so 2x, and now we're here, minus 7 is equal to 0. Now once you factor it, you just set each factor equal to 0. X plus 4 is equal to 0, or 2x minus 7 is equal to 0. So x is equal to negative 4, or we would add the 7 divided by 2, x is equal to 7/2. All right, let me go ahead and erase this. If you don't like the x method, another way that you can do this is eventually to do factor by grouping. So it's essentially, it's very close to what I was just doing, but then there's this, since people forget to divide by 2, there's one other change that you can do. So you take your two numbers and you do 2 times negative, so if there's a number in front of this, you must multiply, so that's equal to negative 56. And then from here, you're looking and seeing which two numbers multiply to 56 and add to negative 1. So that would be 8 and negative 7, just like we did. And then you rewrite exactly what you have, 2x squared, and it doesn't matter which one you write first, your 8 or your 7, but then you write them, and you write these two numbers with your x, would be plus 8x, and then minus 7x, minus 28 is equal to 0. And then we do factor by grouping. So we group the first two together, and we group the second two together. We factor out a 2x, so 2x, so it'd be x plus 4. Here we can factor out a negative 7, and we're left with x plus 4 is equal to 0. And now we can have factor by grouping. Since these are the same, it's 2x minus 7 times x plus 4. So you see, regardless, you still get the same answer, or the same factored form. It's your preference. All right, that is it for that problem. All right, so for 46, I kind of already talked about this one. Remember, if I give you the absolute value of negative 5, well, this is equal to 5. So if I say that the absolute value of x is equal to 5, this actually generates two answers, because the absolute value of 5 is equal to 5, or the absolute value of negative 5 is also equal to 5. So when we're given this absolute value of 4x plus 1 is equal to 3, first thing you have to do is, if there's anything on the outside being multiplied or added to this absolute values, for instance, if it said 3 times 4x plus 1 minus 2 is equal to 3, you need to isolate your absolute value first. So we would have to add over the 2, and then we would divide by 3. But once you have your absolute value all by yourself and nothing being multiplied or added to it, you simply take what's on the inside, 4x plus 1, and you set it equal to the positive number that we have. So if this is equal to negative 3, we know that can't work, but we set it equal to the positive or the negative. All right, because we're not saying that this is negative 3. That's why that can't work. We're saying in here can be a positive or a negative 3, because we can take the absolute value of 3 and give us 3, or the absolute value of negative 3 is 3. So we're setting this equal to a positive 3 or a negative 3. But if we just had 4x plus 1 absolute value is equal to 3, we know, or negative 3, I'm sorry, we know this can't be true, because once we take the absolute value, it's always going to be positive. So that's what I was meaning by this can't be negative. But the inside, we're setting the inside equal to it. So then we solve for each one. Negative minus 1, so 4x is equal to 2. X is equal to 1/2 minus 1. 4x is equal to negative 4, or x is equal to negative 1. So both of these work, because if we substitute in 1/2, 4 times 1/2 is 2. 2 plus 1 is positive 3. The absolute value of 3 is 3. Substitute in negative 1. 4 times negative 1 is negative 4. Plus 1 is negative 3. The absolute value of negative 3 is positive 3. So what we're saying is, well, this inside of our absolute value could be a positive 3, or it could be a negative 3, because we know that regardless if it's positive or negative, it's still going to give us the positive answer that we need, right, for the absolute value. All right, so for number 49, I'm going to show you a common mistake that people do. They say, okay, x squared is equal to 3x. I'm just going to divide each side by x and say that x is equal to 3. You are partially right, but you can't just eliminate your x like that. You can't just say, okay, I'm going to get rid of the x without saying what that x value is equal to, because this actually is going to have two different answers. So for this one, what you need to do is you need to set it equal to 0. So x squared minus 3x is equal to 0. And then we're going to factor. Each of these has an x in them, so I can factor out an x. So I'm left with x minus 3 is equal to 0. So that means x is equal to 0, or x minus 3 is equal to 0. So x is equal to 3. So just like when we divided it out, we still get that answer. But if you divide by your x and it gets rid of one of your values, like it did here where x is equal to 3, that means that x is a multiple in both and that x can also be equal to 0. So if you do not solve it by factoring, a lot of people will forget to write this and they will only get half credit or partial points. We need to remember that if we are getting rid of an x, we have to account for it. Well, if we're just eliminating it, what could that x value be? So in this case, it's x is also equal to 0. All right. All right, so this video is already 20 minutes long, so I'm just going to stop here for this video, and I'll make a second one going over the rest of these problems.